Welcome. My name is Marloes Mul and I'm an associate professor at IHE Delft Institute for Water Education. In this video, I will be presenting how to analyze long time series of climatic data. The analysis will focus on first characterizing the spatial and temporal patterns of rainfall and reference evapotranspiration using standard statistical indicators based on the long-term observations. Secondly, we will be applying the aridity index to identify conditions of drought. Finally, the time series will be evaluated for trends and anomalies. The examples presented in this presentation are based on climatic data from the different governorates in Iraq. All the analysis and results presented in this video can be replicated using the notebooks provided in the course, with the links provided in the description of this video. The reason why we're interested in Iraq is that it's one of the most water-stressed countries in the world. Since the 1970s, temperatures have risen by about 1.5 degrees Celsius. While that increase might seem small, in a hot climate it leads to much more evapotranspiration. In some areas, rainfall has dropped by 10 to 20% over recent decades. At the same time, new dams in Turkey and Iran have sharply reduced the flow of both the Tigris and the Euphrates rivers, on which a large part of the agriculture in Iraq depends. Agriculture uses about 80% of Iraq's available water, and the population has doubled since the 1990s, adding millions of new water users. With this background, let's take a closer look at Iraq's climate. For the example of the analysis, we're using the open access 5 climate reanalysis products. This data is available starting since the late 1970s and continues to be updated. To establish what the climate looked like based on the past 4.5 decades, we focus on two variables, rainfall and reference evapotranspiration, which help with assessing the water availability compared to the atmospheric demand. Although the 5 provides only climatic variables such as temperature, relative humidity, wind speed, and radiation, the Food and Agriculture Organization is offering a reference ET product based on these climatic variables using the FAO 56 Penman-Monteith equation. To describe the datasets, there are some typical descriptive statistics which tell you a lot about the data. First, investigate if the record is complete. The count tells you how many observations you actually have. Gaps, particularly if they occur in specific periods, mean any comparison across groups could be reflecting missing data and not a real pattern. The most standard descriptive statistics include mean or average and standard deviation. The mean gives you the long-term average, while the standard deviation shows how much of the spread around the value is around the mean, meaning a large standard deviation will less likely provide a value close to the mean compared to datasets with smaller standard deviations. An example of how this works is the annual precipitation amounts in the two governorates in Iraq, Erbil in the north and Baghdad in the center. You can see their locations on the map. Mean annual rainfall is much higher in Erbil compared to the center and even southern parts of Iraq not presented here, whereas the standard deviation of Erbil is much larger. Finally, some additional descriptive statistics include the minimum, 25, 50 and 75 percentiles and the max, and which trace the shape of the data without the outliers skewing the pictures. These are often presented using box plots, of which one of them is shown here. Of course, Iraq is known for its historical sites of the first civilization based on the irrigated fields from the two main rivers, Tigris and Euphrates, and therefore the rainfall is not the only source of water. There are other factors that are important for understanding climate and water resources availability. More information can be obtained through assessing the intra-seasonal variability of the variables. This seasonality illustrates a recurring pattern at a specific time of the year. This information can be easily presented by calculating the mean monthly values of each of the variables. For example, the long-term monthly precipitation for the selected two governments are presented in this figure, showing common patterns as well as clear differences. While both areas have a rainy season and a dry season, rainfall in Erbil is significantly higher compared to Baghdad. Comparing this with the atmospheric water demand in the form of reference ET, you can see that the difference between the two variables, is higher in the Baghdad region compared to Erbil, not only due to less rainfall, but also higher temperatures increase the demand for water. Another way to assess whether area is naturally water scarce is evaluating the aridity index, comparing the atmospheric supply in the form of precipitation with the atmospheric demand, represented by the reference evapotranspiration, using this formula. Based on the UNEP's classification, areas in northern Iraq, such as Erbil, are humid to subhumid, whereas more southern areas are arid, such as Baghdad, and hyperarid, even more to the south. After looking into the intra-seasonal variability and classifying droughts, we also interested in how these variables change from one year to another. We are introducing two methods to establish, first, if the data series have significant trends, meaning if the variable is showing an increase or decreasing trend, which can not be attributed to the normal variability observed in the data. The second method looks into individual years and when anomalies were observed in the data. Let's start with the trend detection. One of the most common statistical tools in hydrology and climatology is the man-candle test, which tests whether or not there is a trend. This test is non-parametric, so it does not assume anything about how our data is distributed. This matters because climate data is often not normally distributed and has outliers or is skewed. The test checks all possible pairs of years in the data and see if later years are usually higher or lower than earlier years. If they are, it means there's a monotonic trend. A significant threshold of p less than 0.05 is most commonly applied, which means we accept a 5% chance of finding a trend which is actually part of the natural variability of the data. Once the trend significance has been determined, we can use the descent slope estimator to provide the rate of change. It does this by calculating the slope between every pair of data points and taking the median value. Using the median takes it less sensitive to the extreme values and outliers, much more so than ordinary least square regression. These two tests are therefore complementary. It's possible to determine a slope in a dataset which does not have a significant trend, meaning the slope is likely part of the natural variability of the data. Average values and trends are important, but people are affected by the climate conditions in a particular year. This information can be obtained by doing anomaly analysis. The standard anomaly or z-score measures how unusual a year is compared to the long-term average and standard deviation. A z-score of 0 is an average year. -2 means a year of 2 standard deviation below average, an extreme drought occurring roughly in 2.5% of years by chance. Heat maps such as this one can provide a quick overview of rainfall anomalies across all the Iraqi governorates, illustrating a more regional drought in northern Iraq in 1999 and a severe drought across the whole of Iraq in 2021. Let's summarize what we found from the different analyses we've done to establish a baseline of the climate in Iraq. General descriptive statistics provide the first indication about climatic conditions based on the data provided. For Iraq, it illustrates that a governorate like Erbil in the mountain north receives more rainfall than in area in the center of Iraq, like Baghdad. More information is provided by evaluating the seasonality, identifying November to April as the main rainy season and a hot dry season with high atmospheric demands between May to October. Comparing the two datasets provides insight into when and where irrigation is required to grow crops. Based on the aridity index provided by UNEP, Iraq is considered arid to hyper-arid, except for a few governorates in the north. Trend analyses are important to assess if the changes are part of the natural variability or if there is significant trend observed. Next to the long-term trends, anomalies are even more important as droughts or floods can have severe impacts on agriculture production. Thank you for your attention.